Okay, today during class we worked with this problem, which is mimicking question number 1, A through E, on page number 356. So we have to start with a balanced equation. If the equation is not balanced, you will need to balance it. So going down here, given is always got to start with a balanced equation or an equation that needs to be balanced. And then we get particle ratios, mole ratios, and mass ratios to verify the law of the conservation of mass. And this is the way your paper needs to look. In that first question here, we need to see that we have 2 particles plus 1 particle plus 2 particles, which is the particle ratio. When I multiply particles by Avogadro's number, I will get 6.02 times 10 to the 23rd more. And if we multiply them all by the same number, and then divide that number back out, we will wind up having a mole ratio, and that mole ratio will look like this. And you look at that and you say, hey, it looks the same. Well, this isn't the same, because now we're talking about moles of particles. But the numbers will be the same. And then the next thing is to show the ratios in grams. For that, you have to know molar masses from the periodic chart. And you convert the moles of hydrogen to, because there's 2 atoms in every molecule, there will be a total mass of 2 for each molecule of hydrogen. And because the coefficient here was 2, 2 times 2 is 4, which is where you get that. Here you also have 2, only this time it's oxygen. Oxygen is 16, and 16 times 1, which is the coefficient in the mole ratio, as well as the particle ratio. But that's going to leave it at 32. And then here you have 2 waters. The molar mass of water is 18, and so the coefficient of 2 means that we're going to have 36 grams for every 2 moles of water. And as you see, 36 is equal to 36 when we add it all up. And what we've learned here, and what we learned today in class, and that is that we can do problems 1A through E on page 336 and follow this format, and everything will be good. Now let's go on to the stuff that I didn't show in class, and that has to do with the equation for a bike. And this is right on the video. In most periods we did not see this video, or this part of the video, so let's look at it. And you might remember that in the video we saw that 1 frame and 2 wheels and 1 seat made 1 bike. That is a particle ratio. Well, to get it to a mole ratio, essentially you just have to simply call it moles, but what you're really doing is you're saying instead of having atoms or molecules, you're going to be working with parts of a bicycle. But it demonstrates what you're asked to do in your second and third set of problems. In question number 2 on page 357, you're asked to determine the possible mole ratios for the following balanced chemical equations. And in number 3, you're supposed to balance your equation and then determine the same mole ratios. So let's go ahead and determine those ratios, and we'll do that right now. First of all, we have to get in our coefficients. So we have 1 to 2 to 1 to 1. Now, our first mole ratio can be from here to here. That is mole ratios 1 and 2. Our second mole ratio could be between this guy and this guy. And depending on whether we say W to S or S to W, it will be our second 2 ratios, ratios 3 and 4. And then we have another ratio from here to here, And again, this ratio, depending on which way I go, will give us ratios 5 plus 6. And now we can have more ratios than that, because we can have the ratio not only F to W, but we can go F to S. And so that ratio, there's 2 of those, and that gives us 8, or I'm sorry, not 8, but 7 and 8. And we also get the ratio of F to BK, and that's ratios 9 and 10. Our next ratio will be W to BK. We did F to BK as 8 and 9, or 9 and 10, and now we're going to be doing W to BK as 11 and 12. So what this has taught us is how to do these problems. The only difference between the problems that you see in 2, A, B, and C, and 3, A and B, is that with these guys you have to balance the equation first. Otherwise, these two are going to look exactly like what you saw up above. And one of your extra credit questions tonight is to figure out how many mole ratios you have in a balanced equation if you have 2 reactants and 2 products, or 2 reactants and 1 product. And that's it, folks. Thanks for watching.